This video is going to be on section 5.1 in your college algebra book. It's going to cover homework assignment number 20. We're going to be looking at a system of equations. This means we'll be looking at more than one equation at a time. If we were to look at this graphically, one of three situations would arise. Probably the most common would be this one in the center, where if I drew one straight line and then I drew another straight line, they would intersect in one point. Now that one point would be the solution. Of course it's a point, so it's an xy, it's an ordered pair. Another solution or situation would be if I drew two straight lines and they were to be parallel to each other. Now parallel lines do not touch, so there would be no intersection points. The third situation would be that if you drew one line and then you drew the second line and it fell directly on top of the first one, every point on one line would also be a point on the other line, so there'd be many points of intersection. Now what you're going to be asked to do in this section is to find the intersection points. They're going to say solve the system. So you'll either have one intersection point, no intersection points, or many intersection points. Now, what we need to do in this particular little short video is just to go over some terminology. Let's look at the center situation first. If I have two straight lines and I find that they intersect in one point, I will get a solution. I will get an ordered pair, a value for x and a value for y. Now, that means that these lines do intersect. There is one solution. Now, here's the terminology you need to know. They're said to be a consistent type of equation. Consistent. Consistent means they do intersect. They are said to be independent of one another. In other words, they intersect in one point, but one line does not depend on the other. Now, in the situation of parallel lines, they have no solution because they do not intersect. Now, because they do not intersect, you're going to say that they are inconsistent and they are independent. Now, think about this. In English, the prefix "in" means no, so there's no solution. They're not consistent. They're not dependent. Inconsistent, independent. No solution, no intersection. The third situation, you have a line falling on top of another line. They're the same line, so they have all points in common. Infinitely many solutions, meaning yes, they are consistent, and yes, they are dependent. One line depends upon another line. Now let's just recap this because you need to get in your head what these words mean. If a system of equation has at least one solution, it may have more, but if it has at least one, then it is consistent. Yes, it's consistent. If a system has no solution, it's inconsistent. Now the other terminology is if a system of equation has infinite number of solutions, many solutions, those equations are dependent. If there are not all or infinite solutions, they are independent. We'll be using these words as we work the problems. Now, each of these problems will not ask you to use this terminology, but some will, so we need to get familiar with this. And here's what we're going to be doing in this section. You're going to be asked to solve a system of equations, and there are several methods involved. They can be solved by graphing, they can be solved by substitution, or they can be solved by elimination. Now sometimes the elimination method is called the addition method. We are going to be using the elimination method. Again, if you know another method, you can use it. I'm going to be showing you the elimination method. In the second part of this video, we will actually look at solving systems of equations. In this one, I just want you to get familiar with the terminology.